Hello, in this video we will talk about type of vectors with fixed length. So, what is a vector? Let's compare it with list. Let's say list of integers. List of 2 integers and list of 3 integers are both values of type list of integers, but vector of 2 integers and vector of 3 integers are elements of different types, vector 2 and vector 3. So vector is a collection where information about number of elements is included into type. Here you can see some code in Idris. Idris is a language with dependent types. Here is its official website, and it has good documentation. Okay, so how can we define data type vector in Idris? Here is type constructor. It takes natural number and type and returns type. So for any n and a, vect na is a type. This data type has two value constructors, nil and cons. Nil has type vect 0 and cons has type vect of successor n, and it takes head of type a and tail of type vect n. Type of vector depends on value of natural number n, and we can say that vect n is a dependent type. So how vector type can be defined in type theory? Type formation rule: if n is natural number and a is a type in context gamma, then vect na is a type. So we can say that with respect to variable a, vect na is a type family, but with respect to variable n, vect na is indexed inductive type. It has two constructors, nil and cons. Nil is an element of type vect 0a for any type a in context gamma, and if we have head of type a and tail of type vect na in context gamma, then cons ht is has type vect suc n a in the same context. Regarding eliminator, we will talk we will discuss elimination from vector type in lesson about induction. Okay, so now let's look at some code. For example, here you can see definition of function of concatenation of vectors in Idris. So if first argument is nil, then we just return second argument. If first argument is cons, then we apply the same function to tail and second argument, and then prepend head to the result. In practice you will see some tasks about vector concatenation. For example, implement vector concatenation in Scala plus library proving ground, and implement vector concatenation in just Scala on type level. So let's look how this code works in Idris. Okay, let's start Idris REPL and load our file. Concat first argument cons let it be vector of strings. So we are making concatenation of two vectors, vector AB and vector CD, and the result is vector ABCD, and it has type vector 4 string, because both arguments had type vector 2 string. Okay, it was Idris. Let's return to library proving ground. Let's define some easier function. For example, let's define calculating size of a vector. So here we can see type variable a, vec is an indexed type, and here is definition of type vec as an indexed inductive type. It has two constructors, nil and cons. Nil has type vec0, and cons takes natural number, element of type A, that is head, element of type vec_n, that is tail, and produces element of type vec_suc_n. So, what is the size of a vector? Size is a function which maps vector to natural number, and we will make pattern matching on its argument. If vector is nil, then we should return 0, and if vector argument is a cons, then with head A of type A and tail Vn of type vec_n, then what should we return? So please make attention that type of argument Vn depends on natural number n. So for this lambda we use a different arrow with tilde. M here is a result of our function after application to Vn. So if tail has size m, then after prepending head A, the result should be suc m. Let's check our code. Let's feed it to REPL. I've already started REPL with command sbt mantle test console. Okay. Let's check. Let's define several variables of type A. Let's define vector cons. First argument is natural number, then element of type A, and tail of type vec n. Cons. Let it be vector A, A1, A2. A cons A1 cons. It should be V cons. First center A2 and vinyl. Okay, 0 1 2. Okay, so let's check our function vsize vec. It doesn't compile. Let's check its type. Okay, so first argument of our function is natural number. Okay, so we should call it with argument 3. Okay, and now it works. Yes, 3 with... Okay, so you see this example is not so interesting because in order to call function of size, we have already to know size of this vector, but this is just an example how some function, some recursive function can be defined for vector type. So in this particular case we could just write suc n with the same result. So what is our conclusion? Sometimes it's convenient to include information about number of elements in type. For example, if we let's pretend we made a typo and define concatenation in such way. Let's try to compile it. We reload our file in Idris REPL. Okay, and we see that there is an error message. Yes, type mismatch between NN and NM. So we can avoid such typos. Okay, that's all. Thanks for watching, and now you are ready to do some exercises with vectors, for example defining, appending an element and concatenation of vectors. See you in the next video, and good luck.